Hello students. Today we'll continue the topic trigonometric identities. If you remember in the last class I have explained to you how to derive the trigonometric identities from the Pythagoras theorem, right? So today we'll be using these identities to solve these problems, right? That these are also the identities. In these identities, we need to prove that left hand side and the right hand side they are equal to each other, right? So let's begin. I have taken this identity cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A is equal to 2 sec A, right? So this part of the identity is called the left hand side and this is called the right hand side. So whenever we are proving the identities, we need to prove the left hand side is equal to the right hand side. So how do we go about this? So first of all, we'll write here the solution, the proving part. We'll copy the left hand side, that is LHS is equal to cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. See, this is same as finding the sum of two fractions where we need to find the LCM, right? And here the LCM is 1 plus sin A into cos A, right? 1 plus sin A into cos A. So I'll just give an example to you. This is, let's say, 2 upon 3 plus let's say 5 upon 2. Okay. So how are we going to find the LCM? I mean the sum of these two fractions. So first we'll find the LCM, that is 3 into 2 is 6. Right? Now this is 2 into 3 should be multiplied by what to get 6? That's obviously 2 plus this is 5 into this 2 denominator should be multiplied by what to get 6? That is again 3. So we'll multiply 5 and 3. If you closely look at this, it is simply multiplying 2 and 2 here, 3 and 5 here, right? So here also 1 plus sin A should be multiplied by what to get 1 plus sin A into cos A. So it is clearly understood this is cos A, this cos A, and this has to be multiplied, this 1 plus sin A has to be multiplied by cos A, right, to get 1 plus sin into cos. So this is cos A plus, here we have 1 plus sin A, right? Now this cos A, the denominator cos A, should be multiplied by what to get 1 plus sin A into cos A. So this is 1 plus sin A. So this is 1 plus sin A. No need to put the dot here. Dot stands for multiplication. So if you just compare this and this, what we have done, this is cos A into cos A, right? And this is 1 plus sin A into 1 plus sin A here. So now we'll multiply them. Cos into cos is cos square A plus this is 1 plus sin A into 1 plus sin A. So that is A plus B into A plus B, right? Which is A plus B whole square. 1 plus sin A into 1 plus sin A is 1 plus sin A whole square. And the denominator will keep it as it is, right? Now in the numerator here, let me first write down, this is cos square A plus, this is 1 plus sin square A. Actually there is no need to put this bracket, so I'll just remove it. This is 1 plus sin square A, that means A plus B whole square, right? What is A plus B whole square? Let me write here, A plus B whole square is A square plus 2ab plus b square. This identity you have done in class 8, class 9, right? So we'll be using a plus b whole square out here. This will be a square, that is 1 square, plus 2ab means 2 into sine a plus b square. B square is what? Sine square. So this will be sine square a divided by the denominator. Again, as I told you, we'll keep as it is. This is cos a. Now, we'll bring this cos square a and sine square a together. Right? So this is cos square a plus sine square a, and here we have plus 1 plus 2 sine a whole divided by 1 plus sine a into cos a. So, if you recall the identity, we have already derived the value of cos square theta plus sine square theta. If you can recall, well and good. Otherwise, the value of cos square theta plus sine square theta is equal to 1. So this is 1 plus, this is 1 plus, this is 2 sine A divided by 1 plus sine A into cos A. Right? Now, 1 plus 1 is equal to what? 2. Right? Let me continue on the right hand side. Let me rub this. Okay, I continued here. 1 plus 1 is equal to 2 plus, this is 2 sine A. This is 2 sine A divided by, again the denominator is 1 plus sine A into cos A. Okay, so in the numerator, if you see 2 is common, this is 1 plus sine A, right? If I take out 2 common, then this 1 will be left, because see, when you open this bracket, you need to get same as what we have written here. Now there are some students who say, if I have taken out 2 common, then nothing is left out here. No, it's wrong. Because if you take out 2 as common factor, then 1 is left. Because 2 into 1 is equal to 2 and 2 into sine A is equal to 2 sine A. When you multiply and open the bracket, you should get same as this numerator. Right? So now this becomes 1 plus sine A, the denominator again I am continuing as same, this is cos A. So now you see the numerator 2 into 1 plus sine A divided by 1 plus sine A into cos A. So we can divide this 1 plus sine A divided by 1 plus sine A. So what is left? 2 upon cos A. Right? If you remember the first class, I have told you what is the reciprocal of cos. Cos is equal to 1 upon sec. Right? Cos theta is 1 divided by sec theta. So this can be written as 2 sec theta. Right? So here we have solved this, simplified the left hand side, and we got 2 sec theta, which is our right hand side. Hence our identity is proved. So we can write LHS is equal to RHS proved. And one more thing, here instead of for cos square theta plus sine square theta, I have written 1. Okay, so better to mention the reason here, since sine square theta plus cos square theta is equal to 1. If you mention the reason when you are practicing at home, you will be able to know that you will be able to recall as why you have written 1. Right? And even the examiner who is checking your papers also will come to know that you have the clear concept as why we have written 1 out here. Okay, so this is it. Now we'll move on to the next question. Okay, let me take the next question. Tan, this is tan theta minus cot theta is equal to 1 minus 2 cos square theta divided by sin theta cos theta. Sin theta cos theta. So here we'll solve the left hand side equal to the right hand side. So here the left hand side is tan theta minus cot theta. Okay. Now we know this tan theta can be expressed in terms of sin theta and cos theta. This also we have already discussed in the previous classes, right? So tan theta can be written as sin theta divided by cos theta minus cot theta can be written as cos theta divided by sin theta. Okay. So reason we can write it here, since tan theta is equal to sin theta divided by cos theta and cot theta is equal to cos theta divided by sin theta. Okay, so again just like in the previous question, we will find the LCM. The LCM is cos theta sin theta. Correct? We will put the dot. Dot means multiplication. So now here we have sin theta. Now sin theta, cos theta should be multiplied by what to get cos into sin? So it is obviously sin. So again this is sin into sin theta minus, here we have cos theta. Sin should be multiplied by what to get cos into sin? So again here this is sin into cos. Theta is cos theta sin theta. So we'll multiply this with cos theta. Right? Again, if you remember, this is sine into sine. Actually, it is simply multiplying this and this way, crossing it, right? So sine into sine is sine square theta, cos into cos is cos square theta, divided by cos theta sine theta. But now you see, what is the right hand side? The right hand side has cos in the numerator, it does not have sine. So what I'll do is I'll convert this sine in terms of cos, right? So we know that sine square theta is 1 minus cos square theta. So instead of sine square theta, I'll write 1 minus cos square theta minus cos square theta divided by cos theta sin theta. Okay. So this is minus cos square theta minus cos square theta, right? This will be equal to 1 minus 2 cos square theta divided by cos theta sin theta, right? So this, if we compare the right hand side and this one, it is the same, right? This is 1 minus 2 cos square theta, 1 minus 2 cos square theta, right? And the denominator is sin theta cos theta. Here we got cos theta sin theta. It's the same thing whether we write 2 into 4 or 4 into 2. The answer is same, that is 8. So here it is sin into cos or cos into sin, both mean same. Otherwise you can even write it like this, 1 minus 2 cos square theta divided by sine theta, cos theta. So we have LHS is equal to RHS proved. See, one question always the students ask me, that's all, how will we come to know that we have to use this identity? How will we come to know that we have to use these steps? See, a simple answer to this is you have to practice. You have to know the identities. When a question comes to you, the clear picture of the identities and the reciprocal ratios, it has to come to your mind, right? And when you're solving the left hand side, you have to keep in mind what is the right hand side. Accordingly, you have to change. I'll give a very simple example. Like here, I have replaced, instead of sine square theta, I have written 1 minus cos square theta. Correct? Instead of cos square theta, what if I have written 1 minus sine square theta? Instead of cos square theta, I can write 1 minus sine square theta. That is correct. But writing 1 minus sine square theta out here will not give me the right hand side. Right? So that's why we have to simultaneously keep in mind that what is our right hand side, what are we supposed to get the final answer, and accordingly we have to make the changes, right? So students, I request you, I tell you, practice at least 2 to 4 identities per day. I'm telling you, in a very short time you will be fluent in solving such kind of identities, right? And I also tell you that practice the identities, how to derive the identities and the tables as well, right? In exam, it will save a lot of time, because in case you forget the identities, you will keep thinking and you'll spend a lot of time in exam, and that's a waste of time. So even if you don't know it, you can always derive it and write it in the paper, and then you can use those identities and the tables to solve the problems. So this is this much for today. We'll continue with the same topic in the next class. Thank you.